Next, let's be familiar with some of the terminologies related to mirrors. So the first terminology we are going to discuss is pole. So what do you mean by pole? Pole is the center of the reflecting surface. If you consider a concave mirror like this, so in the case of concave mirror, inner side is reflecting whereas the outer side is non-reflecting. The center of this reflecting surface, geometrical center, this is the geometrical center of the reflecting surface, right? So this is the pole of the mirror. Okay, so pole is the center of the reflecting surface. Next is center of curvature of the mirror. So what do you mean by center of curvature? Center of curvature is the center of the sphere of which mirror is the part. See, if we consider a concave mirror like this, we know this is the pole of the concave mirror, and if we complete this arc, you will get a sphere, and this sphere has got a center. So this is the center of that spherical mirror, and this C itself is the center of curvature of the mirror. So center of curvature is the center of the sphere of which mirror is the part. So this portion is our mirror and this mirror is the part of this sphere. Okay. Next is radius of curvature. Radius of curvature is the radius of the sphere of which mirror is the part. So here we have a concave mirror and this is the pole of the mirror, and if we complete this arc we will get a sphere, and C is the center of that sphere, that is center of curvature, and this distance is the radius of that sphere, right? So this is our radius of curvature R. So radius of curvature is the radius of the sphere of which mirror is the part. Okay, and what is another terminology related with the mirror is that principal axis. So what will be principal axis? Principal axis is the imaginary line joining the center of curvature and pole of the mirror. So this line forms our principal axis, imaginary line joining pole and the center of curvature of the mirror. Okay. So this is principal axis, the imaginary line joining pole and center of curvature. Next terminology is that principal focus. So what do you mean by principal focus? It is a point on the principal axis where the rays of light incident on the mirror parallel to the principal axis converge or appear to converge. Okay, consider a concave mirror like this. I have marked the pole and center of curvature, and also I have marked the principal axis. So consider these rays. Okay, these rays are parallel to the principal axis, right? And such rays are incident on the mirror. And you know this is the reflecting part of the concave mirror, because for a concave mirror the inner side is reflective. So the rays of light has fallen on the reflecting surface of the concave mirror. As soon as the rays fall on the reflecting surface of the mirror, it will be reflected. So this ray will be reflected like this, and this ray will be reflected like this. Okay, and both the reflected rays meet at a point, and this point is known as our principal focus. Okay, so here the rays has converged to a point, to a single point on the principal axis. Hence this point where the rays of light incident on the mirror parallel to the principal axis converge is known as principal focus. And since the reflected rays converge in a concave mirror, we can call concave mirror as a converging mirror. So which is our converging mirror? Concave mirror is our converging mirror. Why? Because all the reflected rays are converged to a single point in the case of concave mirror. Now consider the case of convex mirror. So this is our convex mirror. Here the outer surface is reflecting, whereas the inner surface is non-reflecting. So here this is the pole and this is the center of curvature of the convex mirror, because for a convex mirror, when we complete the sphere, we will get like this. So this forms the center of curvature for a convex mirror. Now this is the principal axis joining pole and center of curvature of the convex mirror. Now what happens when light falls on the outer surface of the convex mirror? Consider these two rays. These rays are parallel to the principal axis, and when these rays are incident on the reflecting surface of convex mirror, it will be reflected like this. So here the reflected rays are not converging to any point. So what we will do? We will extend or extrapolate this reflected rays backwards so that they appear to meet at a common point here. And this point where the reflected rays appear to meet is known as principal focus. So in the case of convex mirror, the reflected rays do not actually meet at a common point. They only appear to meet at a common point. So that's why the term appear to converge has come in the definition of principal focus. So in the case of concave mirror, the reflected rays actually converge to a common point. But in the case of convex mirror, the reflected rays just appear to meet at a common point. Okay, so this point is termed as the principal focus and it will be on the principal axis. Since the rays are diverged here in the case of a convex mirror is also known as a diverging mirror. So which is our diverging mirror? Our diverging mirror is convex mirror. Converging mirror is concave mirror. Diverging mirror is convex mirror. So what is the nature of concave mirror? It is a converging mirror. What is the nature of convex mirror? It is a diverging mirror. Okay, must not confused between both these concepts. Converging, concave mirror. Diverging is the convex mirror. Very important concept. So what is the next terminology? Focal length. And what is focal length? It is the distance between principal focus and pole. So if you consider a concave mirror like this, we know this is the pole, center of the mirror, and this is the center of curvature, and this will be the focus, right? Principal focus. And the distance between principal focus and the pole of the mirror is termed as focal length f. So focal length is denoted by small f. It is the distance between principal focus and pole of the mirror. It is applicable to convex mirror too. Okay. And this figure represents the whole terms together. See, this is the pole of the mirror. This point, which is the center of the mirror, is the pole, and this is the center of curvature, and the distance between center of curvature and the pole is the radius of curvature, and also this is the focus where all the rays after reflection converge. So this is a concave mirror, so all the rays will converge at this point, and this line joining the center of curvature and the pole will be the principal axis. Okay, and this length, the distance between the pole and the principal focus, is called the focal length. And there is a relationship between small f, that means focal length, and capital R, that is the radius of curvature. So what is that relation? It is R is equal to 2f. That is, radius of curvature is twice that of focal length. If you look at the previous slide, you will understand the relation. Here you can see this is the focal length f. And what is radius of curvature? Radius of curvature is the distance between center of curvature and pole. So this is radius of curvature. And from the figure itself it is very clear, radius of curvature r is equal to 2 times that of focal length. And you must remember this relation, it's very important. This will be useful for your numericals. Okay, radius of curvature r is equal to twice that of focal length. Children, that's all about convex and concave mirror. Rest of the things we will discuss in our next session.
That's all for today, my dear children. I'm concluding this session. A YouTube video based on the topic have been uploaded. Please do watch that video so that the concepts will be much more clear to you. A small test will be there followed by all the sessions. So attend the test. After learning the notes, attend the test seriously and post the answers quickly. We will meet in the next session. Till then, take care. Stay home, stay safe. Keep learning. Thank you.